Let's take a look at some of the prerequisites prior to actually studying the Avaya Aura SIP trunking. Going back almost 15 years, in phase one, the DEFINITY product migrated to IP-enabled DEFINITY. And the first attempt to IP enable the G3R was to add a CLAN and MedPro. Now, a 96XX phone wasn't available back then, but I happened to have the artwork, so I stuck it in. And we're showing H323 connecting to a thing called a CLAN and a RTP going into a media processor. This standardization was actually part of the core of H323, so a CLAN, or the media control interface, not really the media itself, the media processing's on a separate interface. And Avaya jumped on this from the very beginning. But let's take a look on the inside and we see what's actually going on. Well, a large switch cabinet, which Avaya likes to call their cabinets carriers. A large switch cabinet would contain two CPUs in a redundant system so that one would be active and one would be in standby. And then there would be a center stage switch, which was a switch of switches. It would interconnect things called port networks. So I'm showing 4 port networks here. The thinking is that you really don't even need a center stage switch if you had less than 3 port networks. And a port network is simply a card carrier that it actually holds the cards to interface with stations and trunks. Some important limitations on this. You could have 1 to 4 shelves per port network. And there was a time slot issue. Only 484 time slots available per port network. But a port network actually divides that number by 2, because if you originate from an A phone and go to a B phone, that actually burns 2 time slots to support the A-B connection. So it's actually fairer to say there's 242 usable calls inside the port network. Now, if we're going to process a call from a port network to another port network, that's when the center stage switch would come in. Then there would be connectivity. Maybe we'll bring it in through a MedPro, through RTP. That's a time division backplane, through the center stage switch to a port network, and perhaps to our called party right there. And this operated in this fashion for quite some time. But the next step, mostly because it was way too expensive to keep the CPUs integrated in the switch cabinet, it was crazy expensive. And at that time, now we're looking like 2000-ish, around those years, it was much cheaper to go buy a server from any number of suppliers, IBM, for instance. And this particular server, you're just going to run Linux. Then, through quite a bit of effort, mind you, the software that we now call Communications Manager was ported to, I'll show 2 Linux servers. It's possible to run them in simplex mode like you see here. So in the duplex mode, it's also possible to take our port network, and as long as we have at least 2 carriers, remember a carrier is a card shelf, as long as we have at least 2 carriers, we can plug in a card called an IPSI. And this was like the decade of IPSI was the big thing to say, because what the IPSI is really doing is it's occupying a spot where a CPU controller would have been, and basically connecting the port network through an Ethernet network to the active controller. And by the way, if we're going to make it resilient, then let's add the second IPSI down here, of course, in the cascaded port network, and connect it to a completely separate Ethernet and switching arrangement, so that if we would lose some portion, it would actually be possible to switch to the other. So now what we've just done is we've basically extracted the brains from the telephone switch, put them in separate servers, and then connected them back, at this time, regrettably, through a proprietary interface, where the IPSI was the hardware king. In fact, a specific IPSI would be called the golden IPSI, and this software wouldn't even run unless it saw this IPSI active, indicating that the software was not stolen. Keep in mind that it is possible to run a port network on just one CM. You don't have to make them resilient. Well, what would happen, for instance, if we were to lose an Ethernet switch, or an IPSI would die, or maybe just a plug gets kicked? If that's the case, then a heartbeat, which is normally running between the IPSI and the active CPU, wouldn't be there anymore. And then an IPSI interchange would occur that you see right here, which basically means to stop using the current IPSI, drop to the backup, and see if you can get back up to the same communication server. Well, the software that was running the IPSIs referred to as Archangel, which is really a software, or almost like firmware, running in the port network that's making sure that at least one of these two IPSIs has connectivity to an active communications manager. It would also be possible, by the way, that the active communications manager goes offline for whatever reason. The IPSI would try to connect, well, not that one. The IPSI through the B network would attempt to connect to the active communications manager. You know what? If this connectivity was still there, if that happened, then the IPSI could drop back to the other communications manager as long as we didn't lose Ethernet connectivity. Otherwise, we'll drop back to the secondary IPSI up through the B network and attempt to regain connectivity to whichever communications manager was left standing. So at this stage, we can kill off either network. The processes will keep running. What would happen if we completely lose the stack of communications managers? And of course, the answer is the system is going to go down. But there's a fix for that. Avaya actually offered a thing called the ESS. Now, the ESS actually permits a backup communications manager stack to run somewhere else. And now we're going to go after some form of geographic diversity. And here's the trick. You name the set of communications managers that you're going to configure the main. Ideally, you have two of these, of course. Now, this is where you're going to do all the system configuration. In the main CM, that ultimately will be downloaded to the ESS communications managers. That's also configured. So in the process then, when we configure the ESS communications managers, we have to define which ESS would be preferred, because that information ultimately passes to the IPSI. You're going to find out it's really the IPSI that chooses, not really the ESS. Local preferred and local only sort of speak for themselves as to the relationship of control. But what we don't want to do is have to configure the main and then also have to type the exact same stuff in again. And here's where Avaya did a really wonderful job. It's possible with ESS registration and database sync that when you configure the communications manager in the core, it will download the ESS, wherever the ESS stack might be. Here's the fine print on that. There's actually no way to go directly from a communications manager to a communications manager at this time. You're going to learn about a thing called processor Ethernet that comes out a little bit later, but at this time, the only way to actually get in or out of the communications manager software was to follow a rather convoluted path. What you would have to do would be to connect to a CLAN, which is connected to control time slots, 24 of them, in the backplane, which then associates to an IPSI, which then can connect to the communications manager. So to make this clear, I actually show you the path that the actual bits have to take. This means that you really can't get directly to a communications manager. You have to go through a CLAN. So a CLAN referenced by an IP address would have to be configured in the communications manager, in the ESS, so that it would know how to communicate with main. Now, you don't have to choose just one CLAN. You can back up with another if you'd want to. But to keep the diagram reasonably simple, I'm showing that the CMM will pull its database synchronization through a CLAN, basically through a 1 megabit per second bottleneck in the G650. This would be the gateway that's configured with the IPSIs to connect to Communications Manager. But the config wasn't that big, and it worked. So what I'm showing you here in the ESS registration and database is that the ESS is now downloading, and he's dropping the new config in. And then every day, unless you set it otherwise, ESS will continue to keep pulling down incrementally any changes that might occur. This was wonderful because you could configure the center point and the ESS would just follow along. That was grounds, when I consider almost like the golden age of the Avaya design, was that this mechanism of ESS was really nice. So now let's take a look at what happens then under normal operation, because this probably isn't obvious. Because you're thinking, okay, the ESS is in charge, he knows he's online, he's back online. Don't think like that. Because it turns out that what actually happens is the IPSI now knows maybe its primary connectivity is up to the core because it wants information right from the horse's mouth. So, and by the way, remember, IPSIs can go directly to a communications manager in this phase. An IPSI doesn't have to go through another CLAN to go through an IPSI. Please don't be thinking that. Because these are IPSIs, they could go to any communication manager stack they'd want to. And if we have the primary set to be the ones at the home network, then here's the active control, which means this communications manager is controlling this remote port network. Now, that's actually desirable because we kind of have the whole network running off of this communications manager. And as long as the network is working, that means as long as the wide area network is there, as long as this CM is online, we really don't need these guys. But what would happen if a WAN killing storm cloud comes along and knocks off a WAN link? Now, if this is the case, the communications managers up here, they're just sitting around thinking, hey, no IPSI's really connected to me, but I think I'm active in my mind, and I'm ready. If whenever it comes to me, I'll start controlling it. During this phase, once the WAN killing storm cloud is hit, these guys are out of service. Now this is going to last a minute, 3 minutes, up to 15 minutes, depending on how you configure it and how aggressive you want to be. You have to be careful with flapping and stuff like that. But whatever the case, let's say timeout occurs and the WAN link doesn't come back. If that's the case, then what's going to happen is the IPSI, not the ESS, the IPSI is going to seek out a new communications manager, one farther down its list, community by community, priority by priority. And in this particular case, it appears as though this is active, and of course we're going to seek out the active of the two communications managers. This guy is now back online, and the configuration is running as if the main communications manager were running. And again, this is really nice because the fallback is auto magic and call processing is resumed. During this phase, we are in ESS recovery. Now, an interesting fact is that an IPSI will stay in this until you push it back. Because the thinking is, well, why make it flap back and connect back up to the main controller? That would take another hit. And we'd lose service again. Don't do that. If we've dropped to the backup, then let's stay there until after hours, and then you would knock off this connection like that, and you'd pop back to the normal configuration, ready to go for the next day. Now, in phase 4, Avaya does another wonderful thing to the product. They add processor Ethernet. Now, to show you the value of this, let's take an H248 controlled gateway, which, by the way, is simply H248 version of what the G650s are doing. They're just using a proprietary connection through IPSI, but there are media gateways nevertheless. But let's go ahead and add an H.248 gateway, and here's the bad news. The H.248 gateway cannot go directly to a communications manager. It doesn't have an IPSI. But arguably, it's using a more desirable protocol. It's using H.248. The IPSI stuff was proprietary. So to connect the G650 to Communications Manager at this time, prior to Processor Ethernet, the only way to connect was through a CLAN, through the IPSI, to the Communications Manager. So now you can see that this particular G650 or 350 is only going to keep operating as if this G650 stays online. So, this doesn't have to be the only way out of Dodge. We could configure maybe another backup path, but we're still going through a CLAN IPSI arrangement. Then along comes Processor Ethernet, and you probably should be thinking, where was this and why wasn't this put in place a long time ago? So the thinking is, well, why have a hardware IPSI? Why not implement the IPSI in the form of software? Because remember, what we want to do is to deceive or trick the communications manager into thinking that it's still controlling a circuit switch cabinet. That's what's going on here. But that doesn't mean that we should make devices like this have to resort to some ugly connectivity through a CLAN like you see here. Much cleaner if we could connect directly. And this is what happens with Processor Ethernet. So basically, the IPSI is virtualized, the software inserted within Communications Manager. Now the Communication Manager server effectively has a virtual IPSI. That means that we can send SIP, H.323, and H.248 directly to the CM. And we don't have to go through the bottlenecks, go through the CLAN and IPSI, which remember is like a 1 meg bottleneck. We don't have to do that anymore. We can go directly to Processor Ethernet. Well, you can see what's going to happen. Then the next step that Avaya is setting themselves up for is, well, if we have this in place and we can design H.248 gateways and we can build this, certainly we can make software for less, and we can build H.248 gateways much less, then you know what? We can make this proprietary G650 stuff go away. That's exactly what they're doing. So at this stage, you say, well, let's completely erase the whole G650 arrangement. And then while we're at it, let's add virtual machine. So we're going to plug in XEN, and then the communications managers, that software is going to run on top of XEN. We're going to keep our G650, and guess what? We're still going to have connectivity directly to Communications Manager, but all of this is now wonderfully virtualized, which means it's software. So the price to manufacture, not necessarily develop, but the price to manufacture certainly went down in this particular case. And by the way, now that we have XEN added, that we go to the next phase, which let's go buy an IMS core from Ubiquity, so that we're going to build our network exactly like the way 4th generation cellular works. This is going to be IP multimedia subsystem. So since we have our XEN platform, the communications managers are still there. They still think they're controlling a circuit switch, but we're never going to tell them. We will cocoon them with H.248, SIP, and H.323 software so that the internals, the bulk of the code doesn't need to know the signaling protocol. All it needs to know is that it's controlling a telephone system, and the fact that it's all virtual, why would the software have to care? We had a system manager in order to manage all of this stuff, and let's add a session border controller to do SIP trunking. At this point, you'll notice what hardware is really left, because if we buy a smoking fast server, and if the server's not powerful enough, then you know what? Maybe we'll load XEN and we'll only be able to run a communications manager on it. Then we'll put another server in, another communications manager on top of that. We may have to rack a few servers if that's the case. But still, they're being offered in a service platform. So along this line, then Avaya says, well, why don't we take this XEN, and as long as it's less than like 2,000 people, let's go ahead and plug Communications Manager in there. We don't really need the backup one. And we'll do the control, our IMS core, which of course is called Session Manager. And we'll plug in a, actually there was a embedded session border controller at one time from Acme Packet embedded in there. Since then, Avaya has migrated from that, but it's still all over a virtual platform. Now, the next step is, if we're in the virtual world, the only piece of hardware really left are H.248 gateways. For as long as we're going to have endpoints and media and things like that, H.248 is actually the best control for basically controlling legacy-ish type applications. That's going to stick around for a few more years, and as soon as we can cut the ties on that and that goes away, this platform should carry Avaya for quite some time. So the next step then, which is the beginning of this course, is to realize this communications manager software is still really controlling that old G3R platform, so that when we actually run the Avaya SIP trunking course, we're thinking that this background that we just gave you is something you should bring, and now you have it. You have an idea of how the communications manager is thinking. Once the CM configuration is understood, as that's a bit of a retrofit, you'll see the clever ways that Avaya actually deployed to make the CM function, even though it's running on top of an IP multimedia subsystem core. Then we hit the entry point of this class, which is to understand what does IP multimedia subsystem look like. In a super dumbed down slide, let me show you that the SIP traffic is going to follow this path, where if I divide it right down the middle, this is called the originating half call. We see the other end called the terminating half call. There are H.248 connectivity from Communications Manager to H.248 gateways, so that if we want to relay the media through an H.248 gateway, for a lot of reasons, we want to listen in to the call, we want to, for whatever reason, we want third-party call control of a call, we may elect to have a relay point. Just bear in mind that H.248 can drop the relay points and make the voice go directly between the two endpoints if you want to. So the media under H.248 control, routing is actually under the IMS core control. So that process would be occurring at the points where I'm putting the check marks. The feature services, even if you're running in evolution server mode, is handled by the communications manager. We're not going to put the feature servers in the IMS core. Notice that there is a little blue surround that's surrounding the IMS core, the session manager. That's security module. You actually can't connect direct to session manager. That would be a security issue. So whenever you go in or out of session manager, it's actually security module that you'll see first. For a lot of rookies, this is confusing because you want to connect to the IP address of Session Manager, and then eventually you will learn, like the rest of us did, you can't get there. You have to go through Security Module. That's the gateway to Session Manager where the routing actually occurs.